It's an absolutely special moment because this is the last talk of this our Professor Valentine Troll. So without further ado, please welcome to the stage the amazing Professor Valentine Troll, everyone.
Thank you so much. Thanks for joining me a second time, potentially. So I'm really happy to be able to talk to you about the current volcanic activity on the Reykjanes Peninsula. It's been spectacular over the last 3-4 years, and we'll be sailing by the Reykjanes Peninsula. We're actually going around it. Right now it's not erupting. It stopped about a week ago, so unfortunately we want to get to see lava from a distance. But it's still warm, I promise you. And I'll reveal right at the end, it's building up again. But it's at a very early stage for the next pulse of the eruption. So right now it's pretty okay. If you have booked a trip to the Blue Lagoon, this is a good window. But don't wait too long. In 3 or 4 weeks, it might be bad again. But I'll talk more about this later. Quick summary of what's going on in Iceland. We talked about this before. Iceland is sitting on the mid-Atlantic ridge. It's spreading at about 2 centimeters a year. That widens the Atlantic. At some point, the Atlantic is so wide that it will start to have edge problems and it will start to subduct, but it's still a very young ocean. And in this middle part, we have Iceland sitting, and Iceland has the additional advantage of a plume or a hotspot, as we call it, that is coming from underneath, producing extra amounts of lava, and that makes Iceland become an island, and then it sticks out. There has been activity in Iceland for quite a while, probably up to 60 million years, but we only see rocks of about 14 million years. The rest is submerged, and it's the gray rocks that I'm showing in the map on the right-hand side. These are submarine deposits of lava, and they go back to the Iceland situation over the last tens of millions of years. The Reykjanes Peninsula, that's the bits that sticks out in the southwestern part of Iceland, and this is where Reykjavik, the capital, is actually located. Believe it or not, 70% of Iceland's population lives on the Reykjanes Peninsula. But, Iceland isn't a big country. There is only about 300,000 of them. So, nevertheless, this is a very populated area by the standards of Iceland, and it's been volcanically active for a considerable time, and that includes historical eruption. And we usually look at the area around the Reykjanes as a complicated fault system. Geologists call it a leaky transform fault. Let me explain for a second. A normal fault means that two rocks break. It's a kind of a sheer, straight fault. It breaks. But this is not quite the case at the Reykjanes. At the Reykjanes, what we have is that it's not only breaking, it's moving, and it's actually opening. That's what is meant by a leaky transform fault. Transform means it's opening up and it creates space, so to speak. So these faults, when they move, they are opening up space. This is where the spreading of the Atlantic is actually happening. This is spreading in action, if you will, and it happens not gradually as a permanent feature. It happens in rupture events. And we had one of those rupture events in 21, and this is when the volcano started again. And we had another one in November 23, and just 3 weeks later, the volcanic activity shifted to the Svartsengi area. So these major faulting events, they do the damage that allows the volcanoes to actually come up in the fractures and cracks. Now I need to point out something else. And that is, geologists are quite good at looking at the rock record. We read it like books, and people have done that, of course, on the Reykjanes Peninsula. And what we see there is there has been several episodes of intense volcanic activity followed by episodes of nothingness, volcanically speaking. So we have episodes of quiescence. And there was 3 such volcanic episodes. One started about 1,000 before we started to calculate time. And then round about our time reckoning, there was a second pulse that stopped, and a third one happening about 1000 AD, Middle Ages. And then we had nothing for about 800 years. And now Fagradalsfjall has started again. And this led to speculations early on. Is this the start of a new episode? So each of these bars there, the purple bars, is an eruption episode for one of the volcanoes on the Reykjanes Peninsula, and the Fagradalsfjall one had a bit longer quiescence, but this is the one that started in 2021. And now Svartsengi, the one to the left of Fagradalsfjall in that diagram, has started as well. So what happened actually? Well, in December 2019 into March 21, earthquake intensity got stronger in the area and reaching a magnitude of 5.6. And eventually, this intensified further and further, and in March of 2021, on 19th of March, an eruption started. A fracture opened up, lava was coming out, and this is one of the earliest photos where we had lava on the soil effectively. And of course, what happens is there's a lot of moss and organic material. It starts to burn, actually. Moss fires are one of the problems. And much of the fume there is actually not necessarily from the lava itself. It comes from the fires, particularly in this image. So, and as we talked about this morning, this was a benign situation in the sense that it was in a remote place. There was nobody living there. There was no danger. You had to hike there for a little while, but you could stand at a reasonable distance and watch the lava. And this was, of course, very, very popular. What happened early in 21 then is several craters opened up, and they formed a lineament of craters, and there the lava was emitted over several hundred meters along the fissure. So here's a few more images from very early on in 21. There we have fresh lava pouring out over an old soil or vegetation. So, and here is the main fissure, and this is one of the main vents, and this is a time-lapse sequence. So this is several days in one video, and I'm gonna run you through this now. I hope the video will work, but yeah, fasten your seatbelts. So this was a day, now we're in the night. And now that's the next day. Of course, there's a little bit of rain every now and then. It's Iceland after all. But you can see within 2-3 days, this valley was filled with lava. So the video is 3 minutes. It goes over the first little while of the eruption, but you get the idea. So this lava is then pouring out. It's virtually unstoppable unless you put some major building measures in there. And there was a bit of snow as well, but the volcano doesn't really care about the weather too much. So it's just producing things. And I wanted to point out here at the right-hand side, there's a little valley. That's a low valley, and that actually was one of the outlets. This valley that was getting filled, the Geldingardalur, that overflew at some point, and then there was also lava spilling over into the neighboring valleys. And we'll talk a little more about this in a minute. So I think you get the idea, so let's move on. Here's a map, and the orange area on that map is where the initial lava came out, and then it spilled into this other valley, Meradalia, on the right-hand side eventually. The little red cones, this is the vents, and they're numbered. We have went 1, 2, 3, 4, and they are numbered according to their appearance. So the oldest one is number 1, then the second oldest is number 2, etc., etc. So this is why the numbers jump backwards and forwards. But these vents were not simultaneously active all the time, and they were not equally strong. In fact, vent 1 was not becoming the strongest of them all. It turned out that vent 5 was the one that prevailed. Let me show you. So this is the initial fissure when the eruption started. So there's a crack and lava is spewing out there. And there now you see a little fissure at the surface marked by the vents. Let me show you here. So here we have one vent, here's another, and here's another. That's the fracture line, that's the fissure that underlies the eruption. So here's vent number 2. This is the second that formed. There's a little helicopter for scale. And this is vent number 3. And this is also vent number 3. And as I said, vent number 5 prevailed. This is vent number 1 here. And vent number 2 is out there. And this is number 5, very early on when he was a little kind of youngster. But at the end of the eruption, the situation looked very differently. And it looked like this. This is vent number 5 now. It outgrown all the other vents. And it's also the highest topographic point there. So this is a good lesson for my students. I always point this out. You may start late, but if you work hard, you can still be really on top of your game. So vent number 5 is a great example for that. So here's a little kind of personal introduction to vent number 5. It's a video, and I wanted to share that with you. So I didn't want to go much closer, but my friend there, he was more bold than me. So, and now we're going to look into the vent.
Oh, they're like 12 levels.
Yeah.
I don't know if it's levels.
And have a look at this part of the vent now.
Wow. Did you just get that?
Yes.
Well, we all got it. It was unmissable, wasn't it? So this is a vent collapse. So when you have a volcano building up very rapidly, it sticks together a little bit, but not too much. And eventually, these things become unstable. It's quite common that these sinter cones, these loosely piled up mountains, they are actually collapsing, particularly when there's earthquake and shaking and things like that. But eventually vent 5 filled and had a lava lake. This was in summer 21, and the lava lake was really spectacular. And the eruption calmed down a little in summer 21, but the lava lake had a strange phenomenon. It actually started to pulsate. So it had an eruption, it was overflowing, and then the lava lake level went down again, and then it was coming back and overflowing, and then it went down again. And it was really intriguing. So here's a drone view into the lava lake. So you see the vent area and the crusting of the lava lake, and there's a new little pulse coming in the far right here that's pushing up, and whenever that lake was full to the brim, it would actually overflow. And here's a few images. The ones on the left is one time sequence, and the ones on the right is another one. So let me quickly run you through this. This was June 8th, 21, and here at 4:49 in the afternoon, the lake level was pretty low, and a few minutes later it was still low, but then it filled up and it was overflowing and had this, outpouring of lava, an outbreak of lava, and the whole show was over just a few minutes later. If you look at the timeline here, 4:56. So within about less than 10 minutes, it actually rose up, the lake level rose up, was overflowing, and then it was back down, just to start a new cycle 10 minutes later. So we wrote an article about that. I'm not sure we actually understand what's going on, but we think it has to do with refilling and water that comes out of the magma. There's so little water in that magma that it comes out very, very late. And if this happens, it could push the magma up and then cause these things. At least we postulated that. Let's see what other workers make of it, and hopefully we're contributing to the debate at least, but very intriguing phenomenon. Very spectacular to watch. These outpouring lavas, they then made lava ponds, lakes outside, lava lakes outside the vents. This is a common phenomenon, and there are several ponds that form. So here there is a pool, I labeled them pool here, pool 1, pool 2, pool 3, and these pools have a crust on top, but they're liquid inside. This is one of the really dangerous things why tourists are not advised to walk on fresh lava, because you don't know what's underneath. But there's always one, you know. Anyway, I'll mention more about this a little later. I also said that lava was spilling into the neighboring valleys, and here's one of those cases. Stunning rocks for geologists, where we have these lava flows going into a new valley, following the low topography and filling up the valley, in this case the Nathagi Valley. Nathagi means the night pastures. It was a protected, safe valley where sheep were grazing at night. And Nathagi is the little valley here in the southern part. Let me show you, this is Nathagi Valley, and I've just shown you the lavas as they come over the hillside here, and we're filling the Nathagi Valley. The big problem with Nathagi was that at its southern end there was the coastal road, and there was big concerns back then that the lava might spill all the way and run to the coast and would actually cut off the coastal road. It did not happen, praise the Lord, but it was close enough. But then the volcano decided to move further north the following year, so the road is still intact. So here's an impression of Nathagi and how the initial lavas were migrating down into the valley, and by mid-June the valley was starting to fill up. Here is one of those time-lapse videos again. They're very instructive. Let me find the, yeah, here we are. There we are. So, the filling up of Nathagi Valley. And now you see that it's actually inflating. So there's lava flowing inside the lava flow, under the crust, and sometimes you see it breaking out at the edges. And this is why it might look very solid, but it's still kind of gooey inside. And this is, of course, very dangerous. You don't want to have your foot in there at all. So this was Nathagi, and oops. And eventually there was a whole lava field spread over several valleys. The map on the right, it's a thickness map, and the darker the colors there, the thicker the lavas. And of course, near the main vents, it's thickest with up to 120 meters. And then, of course, the lavas get thinner. In Nathagi Valley, it's about 5 to 10 meters thickness of lava. So obviously, closer to the vent, the deposits become thicker. And here in red, I circled in the coastal road. And this is the road people were very concerned about. But the Icelanders, nifty as they are, they decided, well, if the lava is going this way, maybe we can put an experiment in. And they dug in some fiber optic cables and all sorts of other cables, just where they thought the lava might be coming, so that they could test whether the cables survive lava flowing over the cables. But of course, the lava decided to neither want the road nor the cables, so the experiment is still unfinished. So, trying this, trying that is what I said. So, this is also where the Icelanders learned to work with the lava barriers, and it's really like a fortress when you go to the town of Grindavik there. There's really barriers, berms around the village in several layers. It reminds me of a volcano onslaught onto the town, and this is the attempt to protect the town. And initially, the lava berms were not so successful, but the Icelanders learned very quickly to work with them. They know the angle much better. They know how to kind of need to channel things now. And I'll show a few slides later. It's been really successful once the volcano shifted over to Sundnúkar. It's a very expensive effort, but it actually did a lot of good. So, the volcano that saved Iceland from bankruptcy, I mentioned this morning. The Fagradalsfjall eruptions were quite, well, benign. Some of my colleagues call it a Disneyland volcano. You could go there even with a mountain bike in winter and warm your fingers afterwards on the lava. And this was very, very popular at the time. This stopped then in September 21, and just a year later, in August 22, a little bit to the north, a new volcano cropped up, Meradalia, and this was a short eruption, 3 weeks. And this is us trying to sample the lava of that. So as you see, much of our field gear was a little improvised, as you kind of do. And many people came to watch that volcano. And the 22 eruption was, as I said, only a few weeks. You can see from the satellite image in the lower part where the area was swelling up, and it already stopped before September 22. It added to the lava field at the time. It did connect with the lavas of the 21 eruption. So here on the left we have in orange the lavas of 21, and then in red over here we have the lavas of 22. A small fissure opened up here at this dotted line, and the lava was pouring down into the valley of Meradalia, partly overlapping the older lavas. So here's the initial fissure of 22 of Meradalia, and as you can see, the lava was then pouring out and filling that valley. And here is one of the little early volcanoes. It's just this little vent here behind my colleague Ariana and myself. And this was actually where the eruption started, but then the eruption shifted to build up the main cone, and this little baby volcano was entirely abandoned. So there is this tiny little volcano, it's the size of your foot, and this was where the eruption started, but it didn't continue there, and so you can still see it today. So here it is, and this is the fissure line. And this is the baby volcano. Again, there's a foot for scale, gives you a feeling of how small it is. And on August 10th, behind me, you see the cone is growing. And then August 12th, the cone is even bigger. It's now just one vent. And August 13th, you see the cone is now a proper little volcano. And August 15th, that's how it looked. It was up to 100 meters tall on the highest part of the wall. And here are a few more impressions of that. And this is a flyover. Let's see if we get this to work. Oops. So, and the lava field was starting to spread to the north, and I'm going to take you to these two blue points there on the right-hand side map now. And this is where the 22 lavas were going over fresh ground and not over older lavas. And here you see the edge of the lava flow. You can also see the lava is quite powerful. It takes larger blocks from the substrate with it, so you quite frequently pick up blocks of material, older chunks of material inside lava. The lava will scoop it up and transport it along. So this was another one of those funny situations. This was 21 lava in 22, and we saw where the lava was flowing, so you develop these crazy sampling strategies. You think you can actually kill two birds with one throw, and that is, here you take a sample of the 21 lava, then you lean back, have a cup of coffee, and then the 22 lava comes in. So you can sample the next one right away, and just wait for a minute, and then you have it. So, and here we see the 22 lava causing a moss fire in the side of the valleys. And then towards the southern and southeastern end of the lava flow, we then have the 22 lava pushing the 21 lava. So here you see broken up 21 lava being pushed by the 22 lava behind. Stunning phenomena for a geologist. This is El Dorado to see these things in action, and really on a time scale that we can actually fathom. So here's broken up bits of lava from the year before. And lovely textures, and it's very easy because you don't have to hammer so much if the volcano helps you with breaking it up. And this is how it looks inside. And I mentioned this phenomenon of inflation, where the lava is actually inflating, partly from flow, but partly it's also from gas. And here you see on the left-hand side the surface, the crust, and inside you see the gas bubbles, how the gas bubbles were pushing against the crust, pushing the crust up, causing the lava flow to inflate, even though there may not be a lot of flow inside. So this is the reason for this inflation that we often see in lava flows after they've been emplaced. So what do geologists do when we're there? Well, we try to understand not only the rock types, but also the phenomena. But in order to understand what's going on, you need to get an idea of all the different rock textures that you see there. So we have lava, of course, but we also have glassy bits on the side of the lava. And we can sample liquid lava, and this is particularly Pohjois lava, the smooth running lava. But when this cools down, it becomes blocky lava. When the lava becomes more viscous and sticky, then it starts to break instead of flow. And we also have different pyroclastic particles. Pyro is fire, clastic is broken. Particles broken by fire, so ash. And lapilli. Lapilli is little stones, it's an Italian term, and this means, well, fragments that are a little larger than ash. So, and here is a few of those to give you an impression. There is glassy, lapilli, and tephra, and then we have different lava things. And in the lower range there, in the lower row, we have some scanning electron microscope images. This is a very large magnification, so you can actually see the tiny little crystals in those as well. And this is what we study to understand where the lava is stored, where it forms, what processes are happening on the way to the surface. One spectacular phenomenon has caused a lot of, well, astonishment at the time, and that was in 21 people reported that they found golden pumice. And this is a piece of golden pumice, peculiar golden pumice. All sorts of strange speculation happened in the internet. The best was that there was a Viking treasure that got molten by magma, and then it erupted. So this was Viking gold. I don't think you should listen to that. So, there's a much easier explanation for the golden pumice. So here's some more examples of the golden pumice. Normal tephra or lapilli looks like the ones below, the black ones, but sometimes you get these really golden ones, and they're really beautiful. But the answer is very simple. It's actually just foamy material. If you think of Coca-Cola, well, the foam has a different color than the main liquid, but it's still Coca-Cola. It's the same thing, and it has to do with the amount of bubbles in there. And if there's a certain threshold of bubbles reached, then the light will actually be handled differently by the material. And it looks to us as if it's different, but it's just a different reflection. So it's not a big deal. It's like the foam on the Coca-Cola and no Viking treasure that got remelted. So, but then when we sample lava, we are going out there and we're taking our materials. We usually take samples of quite a bit of size, and you need to be ready. So this is the packing list for a good geologist. And we don't have to go into details, but it's like in the Scouts. You have to be ready for everything. And it's also advisable to be well prepared out there. So this is me getting ready, because in addition to all the equipment, you have another problem, and that is how to get hot lava in your backpack. It's smart to cool it down, but how do you do this? So you look at the hostel's kitchen equipment, and you find your pots and pans and things like that, and think, oh, this is just about right for putting the lava in. So let's see. And then, of course, you need to think a little bit about this. So you need to think about, where's the wind coming from? What is my escape routes? Is there any other dangers I'm not considering? And you usually come with full equipment. You have a gas meter that tells you if there's too much gas in the area. You carry it low on the body because CO is a very heavy gas and it makes gas traps. So you want to actually get an alarm if the problem is below you and not when it's here. So then you can leave the area. And you would have a thermometer. This is a laser thermometer, so you can measure the temperature of a rock before you touch it. I had colleagues touching rocks before using the thermometer, and it ends in a hospital sometimes, so it's not advisable. So you need to be a little smart about things. And then, of course, you have a hammer and goggles in case something sprays or so, or chips off when you hammer a rock, and you have a gas mask just in case you get into a gas situation, then it buys you a few minutes to get out. So, and then you can sample cold lava. Well, that's a piece of cake. You just go there, you sample it, and you bag it up, put a label on it, and that's it. Hot lava is more challenging. There you need to think. You don't want to have it too runny, but you don't want to have the crust too thick either. So you need to kind of find the right time and work with the lava, and then you can scoop up a bit of liquid lava. We want the liquid part because that's closest to the composition inside the volcano. And this is another one. This is blocky lava. So there you need to also be a little careful because things could actually fall down on you. So this requires a little bit of consideration at times. So the biggest problem you have is thick lava that is flowing in valleys, because that's really challenging. Your escape route is usually limited. It's uphill. It's not good. And there's gas traps in valleys, and the lava may be moving. It may be breaking out at any time. Like here, there's a little breakout, and it may actually change the situation within seconds. So this requires a lot of consideration. My personal preference is to go there when the crust is already a little thick, but you can see the glow inside, because then the chance of a breakout is limited and the lava is not so fast, so you can handle it better. So, and then you set out to sample it, and often we do this not just with a hammer, but with a steel scoop, and that's the one on the right, and this is my colleague Lucas with the reflective helmet, and then let me invite you to join me for some lava sampling.
We're going to take a lava sample now. It's a liquid lava sample, and it's going to come from this place there. So let's have a look if this works.
It's like ice cream.
So this is our sample. We're going to take a lava sample now.
So you get the idea, and then of course you need the little bucket or pot or whatever you have, and you put that liquid lava sample in there. It takes surprisingly long to cool it down, and it makes a lot of steam, and the students call it jokingly making lava tea, and this is then when the sample is ready for bagging and bringing it back home. So then the sample looks like this. It's still a little warm, might still steam a little bit, but once it's at about 70 to 80 degrees Celsius, then it's good enough to put it in the bag, because the plastic bags are usually resistant to about 100 degrees Celsius. So, and then you take a lot of samples. This is our sample suite. And then you do a lot of chemistry. We don't need to go into the details. Suffice to say that we see chemical changes throughout the duration of the eruption. In yellow here, 21. In green, 22. In blue, 23 eruption. And now the Sundnúka eruptions in red and pink. And you see there was this upturn in certain chemical parameters. Then it plateaued a little, and now it's going back down. So we have to think about what this exactly means, but it's very instructive in this context. So, 23, we had another eruption, the Litli-Rutu eruption, very similar type of eruption. On the map is on the right-hand side in red, the lava field of Litli-Rutu. And when the eruption started, it looked like this. At the end of the eruption, there was a big lava field and lava rivers. So this was a short eruption as well, about 2 weeks, but quite significant changes in the landscape. And when you stand on the ground, you see a little bit of fire fountaining. But let me take you inside one of those lava vents. And this is, of course, done by drone imaging, but you get the idea, I think. So have a look inside. It's actually a boiling lava lake. So, and then something changed. And you've seen us lava sampling in kind of, with our improvised helmet and things like that. And then we got this donation. A steel company said, why don't you use one of our fancy reflective suits? And well, here they are, the suits. And it was a complete game changer in the sense that the sampling was identical. But suddenly we had 50 million views on YouTube. So I tell you one thing, if you want to get popular, the suits are great. But the rocks are the same, of course. Sorry, it sounds terrible, but it's true. So it feels a little more safe, but it's also a lot of effort to get them on. So anyway, here's a few more impressions of this, because then it looks like being on Mars or something like this. And people love that kind of stuff. So, here now, the 23 lavas flowing over the 21 lavas. So this was very nice to watch. We see the new lava coming in over lava that's 2 years old. And it flows pretty slow, so you can stand there, take a picture. And here we have the wall of 23 lava rolling over the 21 lava. And here we actually have a peculiar situation. The substrate here is 21 lava. The lava to the left is 22 lava. And the dark material there is actually creeping in 23 lava, this one here. So here we have 3 years of lava, 21, 22 over there, oops, and then 23. And eventually the 23 lava moved in and even touched the 22 lava. So there was one place suddenly where we had the right stratigraphy, where we had the right sequence of rocks, 21, 22, 23. Only one single place where this happened. And of course, you know, you see us there standing as if we killed a lion. This is the place. So this is where all the lavas are on top of each other, and we know where it is. So if you ever want to drill in 200 years' time and get the lavas right, that's the place. So, and I want to talk a little bit about natural hazards now as well. So this was the evolution of the lava field, but it was pretty clear early on, because of the high population density, it's not a good spot. If it widens, then it would be problematic. So we have the international airport Keflavik up there, here on this end of the Reykjanes Peninsula. So there is a major highway here that connects Reykjavik in the top right with the motorway. Grindavik village is down there. The Svartsengi power plant that supplies Keflavik with hot water and energy is here, and the Blue Lagoon is here as well. The initial eruptions were here. It was okay, but then the eruption shifted later to here, and this got more problematic. The issues were obvious, and one of the key problems is Keflavik is the largest international airport. There's only one more international airport in Iceland, that's in Akureyri. That's the other end of the country. So most of the food is actually flown in, and this makes it a little challenging. If these motorways are cut off, it's going to be a bit of a traffic nightmare. It's not going to be a complete disaster, but it's going to be challenging. So then here we have the Fagradalsfjall volcano, the dark area with a little glowing point, and we have the coastal road, that's the first circle, Grindavik town, the fishing town, and the Svartsengi power plant with the Blue Lagoon. And all of these areas are very close to the volcanic activity, of course. Keflavik is here, as I said, the only really large international airport in Iceland. So now there's talk in Iceland whether they need a second airport in a slightly different place. So another thing is, people often ask, is there any problem for air traffic after Eyjafjallajökull 2010? And the answer is not really. These are comparatively small eruptions. So this is one of the clouds. I took a picture on my way to the airport last year, and this is effectively just condensed water. And this is not particularly serious, and it's very low. So here's another one. There's a condensation cloud above the volcano, but it's not an eruption cloud. And this doesn't really do a lot of damage, also not to the air traffic. So, but the problem is, I mentioned the roads, and there is no road that's safe, and this is a complicated map. I want you to only pay attention to the purple or the pink-purple areas, because these are historical lavas. They go back to medieval times, 11th, 12th century, and that means if the activity widens to a scale like we saw back then the lava will actually flow to both ends of the peninsula. And that could mean that all these roads are not safe. They could be cut off. Worse yet, there's an aluminium smelter in Hafnarfjörður, which is in between Reykjavik and Keflavik. I have a picture here in the lower right. And they built it in one of these historical lava flows. The mayor defends the decision to this day, and my friend, the head volcanologist in Iceland, he says it was the stupidest things you could possibly do. So, but here we are. So if the eruptions widen, the aluminium smelter is not in a good place. I give them that. So let's see how that goes. So these are the bigger logistical issues. If things got really bad, we would have to fly things into some of the other airports. Here, Akureyri in the north, and Egilsstaðir in the very east. But Egilsstaðir is a small airport and a long drive, and even Akureyri is a long drive. So air bridges is not that, is probably what we would need to do. There's a small domestic airport right outside Reykjavik, and the big discussion is, should that now be made into a bigger thing? So, but the saga continues, because in December 23, the activity shifted over to Svartsengi, and that's the little green area in the map on the left. So it jumped by a few kilometers towards the west, and a new volcano grew. The type of volcano was identical. It's a sinter cone type volcano, and I'm showing a picture here. The picture is from April 24. So these volcanoes all look awfully similar. That's a good thing, because it means we understand them reasonably well. But what it meant was that the town of Grindavik was suddenly in peril. And here, these lava berms came in. The Icelanders worked tirelessly to put them up, but every now and then the lava fissures broke through the barriers, and then there was an incursion of lava into Grindavik town in spring 24. Luckily, nobody was there. The village was evacuated, but the Sundnúkar lava field is constantly growing now. It's the one in red on the map in the right-hand side, and it's actually starting to be bigger than the combined 21, 22, and 23 lava field. So this is the extent of the lava field on the right-hand side map, and you see the lava berms, and the main roads are usually open. So here, there's a lava berm, the main road is open, but there is a whole fleet of diggers, and they can close these kind of open passages within 2 hours. So when they know the lava is coming, they close it off, and then they protect it. If you look over here, you see the lava berms here. This is these thin red lines, and you see how the lava was flowing around them, protecting much of Grindavik village. It's a big discussion right now. Some people say it may not be worthwhile protecting the village any longer, because by now the damage is so big that the whole thing is more like a pyrrhus victory. It's, we can save it, but at what price and what cost? And this is a big discussion now. People have been offered a buyout, so the government has allowed people to sell their property to the government. Many people did take advantage of this, but not everybody wants to do that. So it's a very tricky situation. So this is a projection now. Here you see the Sundnúkar lavas in blue, and the thickest part is whitish and turquoise, and there you see Grindavik town, and you see the lava berms that have been built around the town, and so it did divert the lava quite successfully. And not only at Grindavik, actually up here as well. This is the Svartsengi power plant, and here is the Blue Lagoon, and there is a lava berm that has been circling around this, and it also diverted the lava here. And this protective measure did work, I have to admit. But it's very expensive to do that, and you have to respond really, really rapidly. So, great experiment. Whether it will save Grindavik, I really can't tell, but it taught us some valuable lessons. So this is the Blue Lagoon and the Svartsengi power plant. Grindavik is just to the top right here behind that hill. That's the hill of Thorbjörn, and behind that is the town of Grindavik. And this was from last year. This is then when the berm behind that little house, this is the parking lot of the Blue Lagoon, got affected. The lava did not go inside the Blue Lagoon, but was diverted, as I said. But, well, some things got destroyed. So here, the house on the parking lot, well, it went up in flames. And here's a little bit of lava now. This is also from last year. And I'm going to give you a flavor of how it feels to be close to lava. You realize pretty quickly there's not so much you can do apart from stepping away. So, and the Icelanders are nifty as they are. They not only build berms and barriers, they also build lava roads. They can actually build a new road, well, a dirt track, on top of fresh lava within 74 hours. The only problem is you must not stop on that road. And I'll give you a little ride in our truck over the new lava road. And have a look at this. It's quite adventurous. You're doomed if you stop. So, and here a few more impressions. Of course, the lava takes down everything, and here
Hello,
we're driving by.
We are just outside Grindavik, and we
I'm
are just
talking already.
passing one of the electricity poles that was taken down by the May to June lavas, and here you can see it. So the pole is still there and the cables, and yeah, we're driving by. We're not allowed to stop on the road here, so but you can get the idea. So the lava has dismounted this one, and the cables are still kind of there. They have fallen onto the lava, and of course this is no longer active.
So, and here a few more impressions. I showed some of these images this morning, and this is the lava incursion into Grindavik, and the one on the right, the photo on the right, always fascinates me. I really don't know how this wooden fence survived the lava close by. It's a miracle. So some magic must have happened. So here's another place, and here's my daughter for scale. I had her out on the volcano last year as a field assistant, and this is the town of Grindavik. This is the Bendy house, and you can clearly see this house is not happy. So there was a downfaulting on one side because the whole area in Grindavik is fractured. This is the problem. It's not only that the lava is maybe, causing damage, it's also the whole ground is fractured. And actually one fatality occurred. A person cleaning up his kind of garden disappeared in one of those cracks and was never found again. They had the fire brigade looking inside, but the crack opened up an old lava tunnel underneath, and there was water in there. So the person is just gone. So you need to be very, very careful about this, and this is why I'm saying I am not sure Grindavik can actually be saved. So, but one of the big questions I wanted to answer is there magma under Reykjavik? Because you can see the eruption from Reykjavik, and that's a big question. It wouldn't be so good if there is a lot of magma under Reykjavik, would it? So we want to solve this. So we postulated several scenarios depending on various works, and here we have these lower three scenarios, and there could be a large magma chamber somewhere deep in the crust or in the upper mantle. Some people have postulated maybe there's magma under the entire peninsula in the crust. That would be the model to the right. My preferred hypothesis was the one in the middle. We're likely looking at reasonably small magma pockets that just erupt whenever fractures allow the magma to come up. It's more like a passive situation, and that would be ideal. You don't want magma to be too active in those situations. So, and what you can do is you can do a seismic tomography. It's like a computer tomography only for the Earth, and we did that. It looks a little complicated. We take these slices, but the really important takeaway point here is that there's one red area here. There's one anomaly, and that anomaly means there is liquid down there. So at about 10 kilometers depth, here's the scale, we actually have a larger anomaly. These little black and gray dots, they are earthquake epicenters, and they cluster just about this anomaly. So if you want to make a model of this, then we postulate there's a larger reservoir down there at about 10 kilometers depth. From the speed of the waves, the seismic waves that travel through, you can make an estimate of how much liquid is in there, and we did that. And we can calculate an approximate amount of lava down there, and we are reaching about 50 50 cubic kilometers. So that's a reasonable amount, but it's not huge. So we're not too concerned. So this is actually good news. It's likely this model that applies. We have some magma pockets, and they're reasonably sized. They're several kilometers wide, but they're not ginormous. They're not under the entire peninsula, and they're certainly not under Reykjavik. So that's the good news. We can stay positive. There is not going to be a volcano popping up right in Reykjavik in the near future. So, that's very useful, particularly when we think about the timeline. In 21, we had one eruption. 22, we had one eruption. 23, and then suddenly things sped up. We had this big earthquake, and then in December 23, things shifted over to Sundnúkar, and then we had an eruption in January, one in March, one in February, one in May, and it goes on and on. And by now, we had 12 eruptions in the area. So my colleague decided that we need a different type of diagram. So she started to draw this diagram here. It's a vertical one with the years as horizontal arrangements. So 21, one eruption, 22, one, 23, one. But then in 24, we have a whole series of eruption. And now we're on 25, we already had two. And the next one will come, and I'm showing this diagram here in the top right. This is how volcanologists can be reasonably certain if an eruption will come or not. This is the upswelling of the ground. So each time it reached a high point, an eruption started, the ground sinks down. Just a few millimeters, but we can measure it. And then it builds up again, erupts, and it goes down. And it does so in cycles. And it did so after the last eruption that only stopped about 10 days ago, and now it's building up again. So it's very small here. Sorry, the diagram is not very good. They restricted the high-quality diagrams recently, but this is where we are right now. So we are after one of those downwards jumps after the last eruption, and now it's starting to gradually build up again. So we have a month, 2 months until we're back for the next eruption. So this is actually quite a safe time to go to the Blue Lagoon. And so don't cancel your trip just yet. So, but the lava field is now also growing to the north. So let's see here. This is the latest maps. This is from July. So the last eruption from July is here in purple, and this is the fissure in red, and the lava field has grown mainly to the east and the north. So the situation is that it seems to go towards less populated areas right now, which is good news, but we have to see how it goes. But there was an accident again, because tourists go there and they think they understand lava, and then they start taking selfies, and they start to walk on the lava taking selfies, and then they walk further in, and then you might actually end up in lava up to your knee, and then you need to go to hospital very rapidly. And this is, of course, not desirable. So don't walk on lava, please. So, but coming back to this time sequence, this is the important aspect here. I mentioned it before. We had an eruption period about 1000 BC for several hundred years, this area here. Then we had a gap of 600 to 900 years, followed by another eruption period up to about 0, and then another gap of about 1,000 years, and then we have this medieval period round about AD 1,800 years break, and now 2 of these systems have come back, Fagradalsfjall and Sundnúkar, and there is a possibility that some of the others may rise up again. Krusavik, the system to the east, I was talking to one of the wardens there. They have a geothermal area, and he said in the last 3 years, the geothermal area grew by factor 4. So something is in the bush there as well. So the big realization is we may be at the beginning of one of those major eruption periods that could last for decades to centuries. And once we realize that, we better get ready, because this is a job for quite some time. So luckily, I asked the Swedish Science Foundation. I made that point to them, and I said, look, I mean, really, this is getting serious, and it's going to go on. And not only is it scientifically important, it's also, of course, societally relevant. And Well, they've been very kind. They just gave me a big chunk of money to do more research there. So I'll be back in Iceland doing more work and hoping to understand the system there better. I thank you very much for your attention. And, well, if you have any questions, please go ahead.